All right, so we are going to start the event. So welcome everyone. So my name is Flo. I'm the Corporate Innovation Manager for the US branch of Choose Paris region. I will be your host today for our tech meeting dedicated to Industry 4.0. So this session will be recorded, so please let me know if anyone would be against it. So I'm going to share the agenda. So this is our agenda for today. After a short introduction of what we do, I'll provide some key figures about the industry 4.0. Then we will move to the fireside chat with our experts, so Eva Gustafsson and Eric Pilon-Gagnel, to discuss the industry and tomorrow's big trends of innovation. Then we will finish this event with a selection of innovative companies presenting their solutions and products. So we will answer questions at the end of the fireside chats if you have any to our experts. I will also try to ask the questions during the discussion. If it's online with the topic. So feel free to use the question feature of Livestorm to ask your question. So. All right, let's jump into it. So with a short presentation of Choose Paris region and what we do. So for some of you who don't know us, Choose Paris region is a catalyst for business and innovation. So we partner with Fortune 500 corporations in order to support international companies willing to expand and set up business in the Paris region. So thanks to our presence and vibrant tech ecosystem located in San Francisco, New York, and China, and of course Paris, we are in touch with over 4,000 international companies every year. So this unique relationship with large corporations on one hand and with innovative, fast-growing companies on the other hand, led us to create the Global Open Innovation about 5 years ago. So through this global program, we organize about 20 events a year to foster business and technology partnerships between large corporations and startups. So since the pandemic moved our events online, it allows us to connect and get in touch with more people, more companies. So it has been a pretty interesting experience. Of course, we're going to organize our tech meeting physically in Paris again this year. So in terms of technologies and topics, we cover a narrow of them. As you can see here, it's AI, it's mobility, retail, health, and you name it. So today we are going to talk about Industry 4.0. So first, I wanted to show you a brief overview of what Industry 4.0 looks like in terms of numbers, trends, and those kind of things. So it is composed of different actors from various industries. So you know the names. It's ABB, Siemens, Schneider Electric, Honeywell, and so on. So of course, those are the manufacturing production companies, but we have a lot of other industries and companies, of course. I'm thinking in the software industry, for example, like PDS, that's leading market and leading the innovation. So here are the key figures I want to share today. I wanted to stop on 3 main figures really quickly to set up the base of our discussion panel. So the first one is that in 2022, the global Industry 4.0 market size was valued around $130 billion based on the McKinsey report. And so on this same report, it's stating that by 2029, the market is expected to reach $377 billion. And last insight, which is in relation with those numbers, is that the compound annual growth rate for Industry 4.0, which is expected to be around 16.3% from 2022 to 2029. Also, the trends and industry where like Industry 4.0 are like a prominent trends today are, as we can see here, are the robotics, of course, industrial Internet of Things, AI, extended reality, and others, of course, like blockchain, big data, etc. So to finish this brief overview of Industry 4.0, I wanted to share this non-exhaustive market map with you. So we designed it based on different players we have identified on the market. It's missing a few actors, of course, but it gives us a good understanding on what's happening these days and the big trends. So as you can see here, we are finding the same kind of topic trends that I mentioned before. So robotics, big data, AR, VR, etc., etc. So I don't want to get into too much details. So if you're interested or have any question, feel free to reach out to me. I'd be glad to share it with you or tell you how we've built it. So before we jump into the fireside chat, I wanted to introduce Thomas Fauvel from Choose Paris region, who's going to say a few words about the different initiatives in the Paris region. So Thomas, if you can join me on stage.
Hi everyone, and yes, my name is Thomas, and I'm leading the deep tech practice at Choose Paris region. I'm part of the team in charge of promoting a vibrant ecosystem in which to locate, and with my colleagues, we provide free of charge services to international companies and talents willing to join us. I just wanted to share today with you that Industry 4.0 relies on many different technologies that are strongly represented in academic and private labs in the Paris region. I would be delighted to exchange with those of you who are planning to expand to France for the market opportunities and the talents. Thank you very much, Flo.
Thank you so much, Thomas. Thank you. So if you have any question or you have a project in like the expansion in the Paris region, Thomas is definitely the right person for you. Thank you so much, Thomas. Great. So we're going to move on with the fireside chat with Eva and Eric. So Eva and Eric, if you can join me on stage. We just need to adjust the camera, adjust the microphone, and they will be with us shortly. All right. So Eva Gustafsson works for Westinghouse. She's the Open Innovation Manager, and Eric is an author and expert in manufacturing VP at Salesforce. But I'm definitely going to let them present themselves. Hi, Eric. How you doing?
I'm great. How are you?
I'm doing great. Thank you. Hi, Eva. How you doing?
Hi, I'm good. How about you?
I'm doing fantastic. Thank you so much. Great. So thank you for accepting my invitation and being with us today. I'm very excited to have you to discuss the different topics today. So maybe first of all, if you can maybe take like a minute to present yourself. Give some context to the audience. Tell us a little bit about you, your organization, or like current like projects or initiatives. So Eva, maybe you want to go first?
Okay, so thank you very much, Flo, and thanks for inviting me to attend the tech meeting. So I'm Eva Gustafsson. I'm the Open Innovation Manager for Westinghouse Nuclear Company. So being the Open Innovation Manager means working with a group of people, and we scout for disruptive solutions and match that with our internal needs to be able to speed up new products to our market, but also increase our operational efficiency internally. So that said, we started our incubator group about a year and a half ago within Westinghouse. So I'd still say we are definitely ramping up. And we have a lot of initiatives going on internally, and of course, one of our focus areas is our manufacturing facilities, where we definitely want to go Industry 4.0, which is a bit quite challenging. Our facilities are quite old, so there is a lot of steps to take to go where we want to go, and the nuclear business is a bit conservative. So yeah, we have our hands full, but it's a really interesting journey. So thank you.
Thank you so much, Eva, for being here. Great initiatives, definitely. Great. So Eric, maybe you want to say a few words?
Yeah, thank you for having me. Eva, great to meet you. Westinghouse, a great company. I was chatting with Flo earlier. Actually, I'm from Canada originally, and my dad used to work for Westinghouse, so it's got lots of history that goes much past that as well. But I am an executive now in the software side of the house, the enterprise software. I'm also an author and speaker and researcher on the fourth industrial revolution, Industry 4.0. I think what's very neat is the blending that we're seeing, right? Traditionally, we used to have like innovation or spin out a company to have a true startup. And we used to have large, structured companies. And now we're really seeing these boundaries bleed and blend into each other, much like we're seeing the mega trends. Flo, you talked a little bit about a lot of those trends coming in, right? In the manufacturing space specifically, you throw some numbers that are, in my opinion, almost conservative, right? I think 130 billion to 377 in 7 year with a 16-year CAGR or whatever you put. I mean, that's one little, let's call it, innovation away from being much larger, much bigger across the board. I think there's a lot of new great research we just released in 2023 that I was going over. And what's neat when I hear you say these big numbers, if you look at a lot of these enterprise larger companies, we're seeing this constant disrupt. The only consistent thing we can predict now is disruption. It used to be like a word we tried to prevent in the past. Now we just learn to live with it. Change is kind of the only thing we know is going to happen. We've gone through pandemics. We went through a whole bunch of other things before that. There's been logistical problems in this manufacturing space. There's been scaling and growing. Some of these companies that are large at the speed of these smaller companies. Yet, if you look at the big focus coming out in 2023 is this operational stability facing these economic headwinds. So it's the first time we're really seeing 62 or over 60% of these manufacturing executives in the US. But again, the world's getting pretty flat. So that affects everyone, right? They're 62% believe we're going into some form of a recession coming into 2023. But for the first time, 70% are actually very positive about their company's outlook, which is very unique. We normally don't get both, right? Even going into the pandemic, we saw this where they were unsure, locked in, freezing. We're seeing some really cool change, and it's still very much technology enabled. But if you look at top businesses challenges, it's still attracting top talent, right? If you look at top priorities, it's capital spending and new equipment and technology. So I think it's I'm not techno optimist or pessimist here. I'm just kind of excited. I think it's a really kind of cool space we're all going into. So I'm honored to be here.
Yeah, definitely. Thank you so much. Yeah, we lost Eva during this, but all good. Great. Yeah, no, definitely very, very interesting. It actually set up the introduction I wanted to make. Those numbers that I actually gave in the introduction, it's based on a report that is stating that it's only manufacturing production. So my first question is really broad and really general. What is for you like an Industry 4.0 company? How can you state it? Because if you have to put those numbers up in terms of like industry as a whole, how do you define like an Industry 4.0 company? Because it could be software, it could be really manufacturing. So what is it for you? Maybe Eric first, yeah?
Yeah, I think traditionally we differentiated that more. I think there were high techs, there was finance verticals, there were large manufacturers. You want my opinion? I think everyone's got to be an Industry 4.0 company anymore. I don't think you have the luxury of not believing in data. I don't think you have the luxury of not leveraging data. I don't think anyone's not trying to leverage, automation and do more with less and all that stuff. And look, who knows what the next one's going to be? We've got instability in different parts of the world. We've got entire industries that are appearing or disappearing. We've got, combinatory innovation that might mean nothing to you, right? And then all of a sudden, I don't want to do the chat GTP thing and get everyone too much into that. But all of a sudden that does matter to a manufacturing company, right? Because now they can automate a lot of this production, and they can use people and engage people for what they want to do instead of writing out long, laborious things. And we could see the same thing in the medical care space, all the way through to manufacturers for medical care. So I really don't feel like there's there's something you have to be. I think the real message for me is you have to be an Industry 4.0 company, regardless of your size or who you are. And if you're not looking at it that way, and I think manufacturers were maybe the later part to the game, right? We weren't high tech, we weren't finance. Manufacturing got to do their own thing for a little bit, and then all of a sudden we saw these like logistic and supply chain issues, and all of a sudden we really saw how complex and connected the world was. And I'm sitting over here south of you in Southern California, but a logistical problem here in Longport really affects Europe, and vice versa, right? Because now the shipping containers building up on wrong parts, and that should have nothing to do with me, but my parts are in there, and that's a shortage for my customer, and I can't, predict my sales cycle as well, and there's cash flow problems. And so the world is so complex and connected now. I don't think we have this luxury of trying to, narrow it down specifically. I think everyone's kind of has to have that mindset regardless of what industry you're in. And I don't know if that's a cop-out answer, but that's kind of my take on it. So Eva, I'll let you give an industry perspective on that.
So I definitely agree with you. And so I think we need it for a lot of different purposes, like, sustainability, being able to reduce scrap and a lot of things. But I also think we need it to just attract people. So from my perspective, to the manufacturing industry, and to some sectors that are, say, being viewed as, say, old-fashioned. I think that's where we need to go, because we need the young people in the industry, and we need those new mindset to be able to further develop how we work. So we just need to go there.
Yeah. I was just going to say, I think you make a great point. I think over 76% in North America's top business challenge is attracting in manufacturing top talent. And you know what? There's an entire shift there, right? Traditionally, manufacturers, heavy back end, ERP, old legacy systems, pretty siloed. That's not what the new young minds and our future generations want to do. They want to come into sexy new technologies, right? And we're seeing this incredible ability in manufacturing to capture data, right? Through Flo, you had them up there, but networks that are colliding now with VR and AR and 3D printing and blockchain, and those maybe have nothing to do with us, but they do, because they create, for the first time in Europe, I think I saw in 2022, wind and solar surpassed gas. So these are huge. To your part, generation be part of something bigger than traditional working for the same company. A lot of them, like it or not, whatever, we can hate on millennials however we want to do that, but they want to be a part of something bigger. They want to change the world. They want to save the world. They want to lean into these initiatives. And I think like you nailed it, right? How do we get more and more of that talent? By bringing in the technologies and the right purpose and the right mission, and all the way through to how we're running these technologies, and what does that carbon footprint look like? And these are things people, the workspace traditionally, I would say even 5-10 years ago, you would never even worry about that. Now people will, to an extent, take a little bit less money to work for something they believe in than to work for something they don't believe in, right? And I think that's a major shift we've seen, even probably pre-pandemic, but especially during the pandemic.
Yeah, and that's actually mentioning the pandemic. I think that's something that struck me very much when I was thinking about it the other day, is how we were discussing with our facilities, like, say, 3 years ago, and everything was impossible. The cloud was impossible, wireless networks were impossible, and then the pandemic happened, and then suddenly a lot of those, say, basic structures were implemented. And I think that's, of course, like all people, I wish the pandemic hadn't happened, but it speeded up some things. It made some things happen faster.
Yes, and the epidemic was terrible, right? The pandemic was terrible. So, you know, I'm with you. I'm not saying that's good, but it did force disruption, and that forced our hands. And I think you see that across the board in industry, and even manufacturing, a pretty old rich industry. It adapted. It actually did pretty well through the pandemic. We fought through like logistical and supply chain issues and a lot of that stuff, but and there's still economic headwinds, and I'm not saying we're out of it, but that shift made it. Then you look at some other old archaic industries, and I'm not going to hate on it, but education in general, where we traditionally batch process children, like they weren't ready for this disruption. They hadn't, at least industry had put in a foundational element that allowed us to scale the disruption. There are certain parts that, you know, had, you know, a lot of trouble. All of a sudden it's like, I don't know, send a 7-year-old home and homeschool him from it. We just didn't think through a lot of these things. So I think manufacturing and a lot of these industry in general did well, but there are parts that definitely weren't able, to your point, to, you know, scale. So
yeah. And so we talked about a little bit about the drivers for Industry 4.0. I wanted to back on this a little bit more. What are for you the different drivers for like Industry 4.0? Is it like globalization? Is it like digitalization? I know Eva, you talked a little bit about talent. Can you like talk a little bit about this?
I'm sorry, I heard you very badly because you broke up. So could you please repeat it?
Sorry. I was talking about the drivers for Industry 4.0, kind of like globalization or like the digitalization. You talked about the talents, which is like very important. Can you tell us a little about the drivers, like those kind of things that you see?
Well, I see other drivers is actually, I would say, the digitalization, by being able to, you know, for our company, for Westinghouse, I would say that being able to access and to process all the data we have is very, very important, because right now we have tons of data on handwritten sheets. And so the first step would be to just get it into the system. The next step would be to actually, you know, feed it into like a digital twin, to be able to utilize its, capabilities to optimize our manufacturing process, for example. And as to what Eric mentioned before, also connect that information that we can get out of the manufacturing process to supply chain, to logistics. So I think that's a very important part as well.
Eric, yeah, on the drivers.
Yeah, I mean, I think the megatrends are going to continue to be the drivers from a very 30,000-foot view, right? You know, I think you're going to see breakthroughs in biotechnology and material sciences and nanotechnology that you think are unrelated, but they suddenly change something in a completely unaffected industry that opens up a new world, right? A breakthrough in blockchain lets us learn about some amyloid protein that fixes strokes, and then all of a sudden we can use a lot of this algorithm to streamline our processes internally in an industry, in a company, and stuff like that. So I do feel like this big interconnected, these mega trends, your networks, your VR, your AR, your 3D printing, all this fun stuff is going to say. I think the big one is, I think I have two. One, and they're gonna build off of each other, and I think Ava nailed it right. I think if you look at larger, like the Westinghouses of the world, companies who have addressed this change they need to make, I think on average, they've got 1,000 applications that they're using. And I think when you do a true kind of audit, I think 70% of them remain disconnected from one another in some form or from the core business. So you've got app rationalization efforts, you've got siloed systems, disconnected data sets. Like, everyone wants data, but if we're not bringing it all together, and we're getting better and better at this, I think we also fall into sunk cost fallacies. And you know, we spent money on this, so we should use this, when maybe it's better to just kind of scrap that and move more and more. And I think impossible was a question we used to say all the time that really kind of means 5 or 10 years now in our world, right? If you look at where we are now with the cloud, Ava, like what you said, what we did, unfortunate reasons for the disruption, like we shifted entire industries. I mean, the largest companies in the world online overnight with relatively less disruption than we ever would have thought we could have done to our business. And I think that brings me to speed. I think I don't want to go into this chat GDP thing and I don't want to touch that, but I think when you look at, you know, why I'm, I guess, bullish on your 130 billion to 377 billion is that's really looking at the large enterprises, right? These big Westinghouses of the world. But you've got this weird model like that we go from freemium to premium, and I don't remember I don't remember the actual numbers, right? But it took Netflix like 2.5 years to get 100 million users. It took Instagram, whatever, a year. OpenAI released the ChatGPT and had 100 million users in 5 days. Now that was a free offering. Now Spotify did the freemium to premium, about 27% converted to premium. Dropbox and Evernote, and some of these are lower, 4%. Google Drive's 0.5. So I mean, if you got a company like an OpenAI that overnight in 5 days gets 100 million users and converts 1% of that, and they're $20 a month, I think, you know, that becomes scary really quick. We have now players in this industry, you know, that we never even looked at. You're talking about a $20 million MRR monthly run rate. That's a $240 million business that didn't exist 5 days ago. I mean, it's really incredible, and I think we're going to continue to see that. And I think the companies large players have learned, right? There's a reason why Microsoft went and dumped a bunch of $1 billion into that right away. You can't buy that speed, and I think as long as companies stay the agility piece, I know we've been saying this forever now, and it's going to be more important than ever because I think the change is just going to get faster.
Yeah, definitely. And so you mentioned like big companies, of course. I had a question actually. Does Industry 4.0 viable for large production facilities only, or is it like for small and medium businesses? You know, are they like, will they also like benefit from Industry 4.0? Because you mentioned at the beginning that every company should like look into it and be like an Industry 4.0 company. But so far, what can we see on the market? Is it for large production facilities, or is it also for small and medium? What would you say? Eric, yeah, or Eva? Yes, Eva.
Yeah. I'd say it spanned from everything from like the smallest company to the biggest corporation. I mean, I have seen, just taking an example of how you can be the deskless worker on the shop floor needing like a work instruction. I mean, there are solutions that would fit a small company for 5 people with quite, you know, cheap and inexpensive solutions to like enterprise solutions for the same thing that would be more suitable for the larger corporations. So definitely, I'd say this is for everyone.
Mm-hmm. Okay. Eric, the same.
Yeah. I mean, I couldn't agree more. I think Clayton Christensen, like Clayton Christensen, wrote this book almost 2 decades ago called The Innovator's Dilemma, and I think it's more true today probably than it's ever been. I think it is for everyone for a lot of reasons. I think they're different battles they fight. I think Ava, you mentioned cloud, right? Like, how we move everything to cloud, and you know, now look, what's amazing and wasn't capable 5-10 years ago was the big industry companies. They would build these things in-house. They would have on-prem, they would have huge IT support systems. That exact same enterprise software tool they are using now that they pay per user on in a SaaS model is available to a person with 3 people in their company. I mean, that is incredible. And what I mean is the smaller players, they've got different challenges. I think the larger players are fighting the famous blockbuster Netflix. It's not that they don't know this disruption's there. It's how do you move away from your profits and your shareholders and your stakeholders and where you make your money and address this market that currently has no money in it, but it's going to grow into something. And so I think it is totally for everyone. I think, you know, the talent, we talked about that a bunch. I think it's still very real. I think robots aren't going to replace us, at least in our short-term lifetimes. But now you can sit and have talent all over the world. I mean, that's incredible. We used to have to build these hubs and have these people come in. Now you can have specialists all over the world. You know, we are sitting here, strangely enough, in different parts of the world talking, whereas traditionally, and I think there's a lot of value still getting relationships and white eyes and being in person, but we do get to do a lot more of this. It's almost like information overload if we're not careful and we don't prioritize our time. But it is, I think it's for everyone, because I think the smaller players can scale now faster than ever before, and it's just it's a different challenge and threat for them as it is for the larger ones that are trying to kind of navigate this future.
Yeah, and so since you both saying that it's for everyone, would you say that there are any barriers to implement those Industry 4.0 models, or like it's pretty easy, like giving like the current like data market and the way that things are happening in the market? Eva, would you say?
I pass on that one. I hand it over to Eric.
I think you cut out just a little at the start, but was the ask on what the lift is to implement some of these Industry 4.0?
Yeah, I was talking about the barriers. Are there like any barriers to do so?
Yeah. So, man, yes and no. I think there definitely are barriers. I think they're different. I think the reality of it's easier than ever to start a company, right? I don't think you need to rent out a space and pay for salaries, and people can do stuff in their part-time. I think because of that, we went through this real fun, glorified, sexy, you know, the Facebooks, all this, you know, garage built out of the garage stories. I think it's shifted a bit back the other way now. I think that's hard only because there aren't 100 companies. There aren't 1,000. There's probably like 10, 20,000 new companies coming out a day now, because it's just so easy to start up a company. But at the end of the day, there are things we still need, right? We still need processing power. We still need capital. We still need, you know, a lot of these things. And again, different challenges, but those keys are really held by the big players, right? You know, all the your NASCAR slide with all the logos there are the Westinghouses of the world. And I think what's really neat is these companies have also learned now that they need that nimble and flexibility, right? They're opening up, you know, like you're saying, like innovation centers and all this kind of stuff as well. But I think you're seeing companies more open to buying up some of these smaller companies, as opposed to in the past they would just try and do it themselves. So I think you're again seeing a bleeding into the industries. I think it's harder than ever to have a true small startup. I know money's more available than ever before if you have the right ideas, but I do think that that's narrowing a little bit, and maybe not as easy as it was, let's say 5 or 10 years ago when we didn't quite understand this .com bubble.
Nice. Great. Yeah. So I wanted to touch on another subject around like innovation, because we talked about a little bit about it with the AR, VR. Do you see any like revolution coming to 4.0, like Industry 4.0? Do you think like something is really going to like disrupt or like make a big revolution like from this industry? Eva?
I just have to say it. ChatGPT for the paperless worker on the shop floor, and he will get his references when he does his search, so he could even like verify that the answer is correct if he needed to. I'm sorry, I just needed to say it because that's where I think we are going.
Yeah,
definitely. I think that's right. I think that's a great example. I think this is, again, there's different forms of innovation, right? I think that one gets a lot of buzz, and it's really a combinatorial kind of innovation. And that's what I think you're going to answer your question, and Flo. That's where I think you'll get it. I think you're going to see major breakthroughs like that when you're combining some of these mega trends, right? When you're combining, you know, networks and VRs and ARs, or what does Chat AI have to, you know, ChatGPT and OpenAI have to do with robotics? Well, it doesn't. But now if you're pumping that into robotics, it very much does. Now we're going to see, which we see all the time, right? It comes out at first and we can't believe it. And then the next thing the industry focuses on is 1% of the time it's still wrong. And that's all you read about, all these mistakes it makes. And like, if we had humans that made only 1% mistake, we would take that all day long. But I think we get this very like taking our jobs, it's ruining everything. And I don't. I think it actually lets us do what we love to do more versus letting us be less of a machine, which is valuable. And I think anytime we bring that together, and it's an interesting one. We were talking about it here, and Ava probably fights this a little bit. OpenAI is fun. It's this cute little harmless company that can't really make a mistake, and if their AI doesn't do it right, it's not the end of the world. Whereas Google's had this exact same technology for a long time. So for a friend of mine that I used to work with was the head of product at OpenAI, and has just left for whatever his reasons. But Google is more sensitive, being a large company and a brand, on releasing this, because if Google's AI did what this OpenAI did for this ChatGPT, the backlash would have been very different, right? Oh my God, how can you do this? I think what people don't realize is we don't take these AIs in industry and open them up to the World Wide Web and all knowledge of mankind. We take them to our companies where we have data in certain areas, and the data is somewhat structured, right? Even in an unstructured data lake, it's not the whole wild world. It's ERP systems, right? And CRM systems and front-end systems and customer data. And all of a sudden then we're automating a lot of the work, or we're discovering trends we never even really thought about or noticed. And we get to be more proactive in our business to our customers, all that stuff, versus being traditionally more reactive, because, you know, it's hard to pull it all apart. So I think I think you're going to see, I call them rogue waves, but these waves kind of colliding. And it's not that any of this is like all that earth shattering new. I think it's just when we combine it the right way, you see these incredible results. And I think that's going to kind of keep happening.
Eva, anything else?
No, I'm good. I agree.
Yeah, in terms of so would you say that, like, because you talked a little bit about this, human like replaced by machines? That's the big question, right? I saw recently like an article about exoskeleton for workers on the shop floor encountering fatigue, weaknesses, etc., and they were testing that. So do you see that coming, like on like a big level, or like is that just like prototypes and it's ideas that will never come out? Eric, for example, or Eva?
Yeah, I mean, I think Ava will have probably a more applicable example than I will, but I do see that, and again, I think I tend to want to see the good in that, right? If I'm lifting a lot of boxes now, and all of a sudden I don't need to get a surgery at 57 for a lower disc that I've blown out over 40 years of, you know, wear and tear, I think that's great. I think back to what we were saying before, that kind of stuff is neat, but it bleeds into everywhere. I mean, once we start to understand cognitive performance and right, how do we stimulate certain actions which releases, you know, serotonin in our brain and excites us and engages us longer, and how do I feel like I'm not working but I'm playing a game? I'm getting way more production out of my employee, right? They're much more engaged, they're less likely to leave, there's less overturn. Like, so I feel like it's not just, you know, traditionally like we look like robots, and I think that's what we freak out. I think there's other parts of it as well, right, where we can, and again, that's the breakthrough, maybe neurosciences that we don't think would affect us, but it does, because if we can have our employees more productive and happier and less burnt out, all these things are very important. So I think it's all really going to bleed together. But, you know, I do think you're going to see more and more of that. I think we're starting to value the human aspect and humanizing things a little bit more, whereas, you know, we don't whip, you know, we don't beat our employees to do their job and make sure they're, you know, doing these metrics and lifting that as much, knowing there's health concerns, right? So, and I think we've seen it. We haven't noticed this change. We tend not to notice change that's happening, but we have seen this. You know, not that in our lifetime, people used to wrap pipes with asbestos. And then we learned, unrelated to our jobs, that gives you cancer. So now we wear masks. Like, there's stuff like that we've been doing. And I think, Flo, to your point, that's kind of the next step, right? We're going to see these significant changes through robotics and VR and AI and all this kind of stuff. And you're going to see it through 3D printing. Now I don't need to lift anymore. We can actually print out some of these prototypes, which is great. And it doesn't, the battle of like, does it replace humans? I don't think so. I think it repurposes that. And I think you've got to be open to reskilling yourself at a faster pace. I think that's going to be the bigger changes in the future. And I think that's always going to be there. I think if you want to do the same thing, you know, like my grandfather did, who also worked for Westinghouse, you know, for 45 years or 47 years, doing the same job every day. I think that time has passed. I think you're not going to get that anymore. But I think as long as you're open to reskilling, restructuring, continuously learning, you're gonna be able to benefit from all these things.
Mm-hmm. Eva, on the machine, like replacing human, like not really?
Well, I definitely see machines replacing humans in certain situations, but I also see in a lot of those situations you may not really replace. Well, the machine may replace a human for a certain task, but that human can go, you know, develop the skills and go ahead and move on to do something that is more, I mean, stimulating for the person, and I think that will benefit the companies and, of course, the person as well. So I think it's not from my perspective, that's not the say downside. It's more about being able to avoid, you know, people getting hurt at work and being able to give people more stimulating tasks at work. So that's how I see it.
Yeah, and Eva, you make a great point, right? It's almost like a competitive differentiator. You almost don't have a choice to do, right? Because if your competitor does that and people can go there and be more stimulated and maybe less likely to get hurt, why would they go work for you when they can work for someone else? So I think these are good things that force us. I also think you brought up something that made me think a little bit about when we're going through how much change is experienced in a unit year now compared to 100 years ago. I think we're going through like 100 years of change in 1 year. We don't always notice this change as it's happening. Flow, right? Like, how does robotics going to work? Like, I don't know. We used to have horses, and then we had steam, and then we had internal combustion engines, and now look like hydrogen and electric cars and things like that. And traditionally, we've experienced this over a longer time, so we don't feel it as much. But some of these changes, I mean, these companies are turning into $240 million companies in 5 days. I mean, if you even said that 5 years ago, someone would have told you that's impossible. You can't scale that fast, right? That's where we're at, though, and so I think we're seeing this change, and I think I think Ava nailed it. 100%, we will automate stuff that will replace human jobs, but that's the argument is hopefully for the better, as long as we can be proactive enough and model that out and understand when it's coming. One, so people aren't impacted. There's livelihoods. We can't just lay off entire factories and have them skillless and jobless, and now they're out in the world, unable to support their families either. So I think we need to, companies and us as a whole need to proactively think through a lot of this stuff, right? We know it's coming. We don't have the excuse of it's not going to be there. So what are we doing with these people? How are we, leveraging them, retraining them, helping them, one, from a human society, view, but also like as a competitive advantage. I mean, if the company repurposes me and I have more value and I'm happier than ever before, I'm going to stay with that company. Like that is a great thing the company's done for me. And I think it can be a competitive advantage if we model it properly as well.
I definitely agree with that one. And not only it will make you stay, but it will also attract new people. I mean, and that's kind of what I discussed in the beginning. I think that today it's really needed because there are so many cool high-tech companies out there that are sucking up all these new young people having all the skills we need also in the, say, conventional industry. So that's really important.
Yeah, and so you're talking about, yeah, go ahead, Eric.
No, I was just going to say, and especially right now, at least in the US, and I would imagine, and I don't have the numbers, so I don't know exactly for Europe, but tech in general kind of went nuts and way overhired through this pandemic, and there's been some cuts, and it's all over the news now and stuff. But there's incredible talent that is out there right now that I think industry has an incredible opportunity to bring in. These are everything we're talking about, right? Are the leaders of the future that are going to take us through this crazy world when we're all going to retire and be old and live on machines or something. But there's a great opportunity for industry, right? I felt like it flipped a little bit, and we see this flip flop. Everyone kind of didn't leave industry, but kind of left industry to like the sexy, fast forward tech, and now industry's come back around. There's more than ever instability in some of these fast forward technology companies, and startups was like the cool and sexy thing. Now people want some stability. That's get that in startups as much. So I think there's a mixed bag of both. People have the flexibility maybe of working from home and doing a bit of their own company that they love and working, you know, as more of like a hobby pastime and working for some stability in a company. I think that's a huge industry opportunity here. One, for startups to grab talent that normally would never be available, that's suddenly available, and industry in general to really kind of go after and proactively. I mean, just read the headlines. You want to know who to go after at a company? Read the headlines. I mean, it's easy. It's all over. There's tons of talent being released, and the talent that's not being released, it wouldn't hurt to network with them because they might be considering moves for, you know, more stable, secure kind of markets as well. So I think it's an interesting, fun time. I don't know. I think, take it for what it is. It's nerve-wracking, maybe instability in general, but I think it's a neat time and a great opportunity in the market, especially with the digital transformations and shifts that have happened. This isn't a new thing anymore, even in the manufacturing space, right? That was new 5 years ago, maybe, but yes, we've started it. Yes, we need a lot of help. You are a great, you know, mind of the future, hardworking. Like, how do we bring you in and how do you help? I mean, that's something a lot of these young minds want to be part of, right? They want to be part of that. Not telling them they've got to go work on this ERP system from 50 years ago that we maintain ourselves still. It's, you know, not always the funnest. So yeah.
Definitely. And so are there, like, for you, because we talked about those industries like coming together, a lot of like startups growing super fast to enter this world. Are there any industries in particular leading the innovation? I don't know, like from my side, I'm thinking transportation, but I don't know. I had like this question, like, are there any industries in particular that are leading the industry, like the innovation in Industry 4.0? Eva, do you see anything coming?
That's a hard question. That's a tough one.
Yeah.
Yeah, I pass on that one.
Eric, yeah.
Yeah, I'm going to skirt around it because I don't have the answer. I tend to talk too much probably, so you guys can cut me off if that happens. But I think it's an interesting one. I don't know if it's going to be one sector as much, but I do feel like you mentioned, right? Like, let's take logistics, and all of a sudden they never maybe leveraged as much data, and now they're very incentivized to get that back. And we've gone through, let's call it this supply chain logistical problems we have, and maybe that's what forced them to beef up their transformation the same way many of us got forced to work from home. And you might look like you're hearing a lot of that, but again, a lot of that can be reapplied, you know, to different parts of your organization, even workflows within your organization and automation within your organization, a lot of that stuff. So I don't know if it's going to be one industry as much. What I find, and I hope, and you mentioned that, is it bigger companies? Is it, you know, industry specific? Is it smaller companies? We've chatted a few times now about OpenAI's, you know, whether it's Bing Chat or Chat GTP, or I say backwards all the time. I do wonder, and the one that concerns me a little bit is what we're doing ethically as we evolve some of this stuff. This is getting into very different territory from when we have, like, building a robotic arm to move a part on an assembly line is one thing, but when you're getting into human manipulation and cognitive manipulation and possible breakthroughs on, you know, how we stimulate parts of the brain to make you think longer or faster. I mean, there's lots of pros and there's equally obviously lots of cons to this. And we see the bias built in to these things traditionally through complexity. But, you know, that's, again, our human bias. And I don't know if we want all these technologies and all these breakthroughs to only be run by quarterly revenue reports, right? I don't know if we want that to be driving it versus, like, some of these technologies are bigger than our industry even, and how we're going to evolve them. And when we do stuff in industry sometimes, and we're publicly traded companies and we've got deadlines and we have to release, and, you know, product gets a lot of pressure and they need to continuously put stuff out, and maybe we vet out 98% of it, but not that other 1%. How is that reapplied in other parts of the industries? Could be for better or worse. Like, there isn't general governance on some of this stuff. If you look at us globally, there isn't. I mean, how you look at data and how data is protected in the EU versus the US versus Canada alone is completely different. And how you innovate in systems that need large amounts of data is very different, because the more data the system gets, the better it can learn. Well, I'm just talking about the West. When you enter how data is viewed in, human data and all kinds of data in other countries and parts of the world, like China, for example, right, or Russia, their governance and how they're running these systems are going to be different, for better or worse. I'm not taking any political stances. I'm just saying, when you have different access to data, your systems can grow and learn possibly faster in some of these things. And these aren't things we want being driven by, certain companies. Maybe there might be some larger things. And again, like, I'm not saying we want to put in our ethics. Had we built in our ethics into systems 100 years ago, we would be very disappointed in ourselves right now. So I'm not saying we have the answer now. We can even build in the ethics. I'm just saying, how do we let these systems continue to kind of grow on their own without biasing them too much, but also not fixing our ways, right? I mean, if we went back hundreds of years, in North America here, and we put in this is ethically what we should do, we would look forward now and we were being like, what the heck were we like? There was slavery back there. There were things that we can't even get our minds around anymore, right? So I don't know. Again, we're moving a lot faster. So 20 years from now, 30 years from now, ethically, there might be things like, I don't know, making it up. I don't know, forcing kids to go to school. How do we do that? It's child abuse. I'm obviously making that up. But I think that's going to be a bigger one, where industries and companies are going to have to take a bit of ownership there, and we're going to have to continue, I think, to try to work to come together for a greater good across cultures, companies, regions, industries, everything. So that's my rant. Sorry.
Yeah, thank you so much. I see that the time is actually flying. I had 1,000 more questions for you. Unfortunately, it's time to move to the second part of the presentation. So thank you very much. I will definitely be glad to welcome you again, Eric, to another event to discuss more. Thank you so much for joining today.
Thank you for having us.
Thank you. It was a pleasure.
So yeah, pleasure. Great.
Thank you.
Great. So we are going to move in with the presentations. We're going to start with Glartech. I'm just going to show the different presentations today. So we are going to start with Glartech. I believe he's here. Shakil. We can invite him on stage. We're just gonna wait a few seconds for him to join us. Seems maybe gonna move on directly with Thomas from Semantics. So maybe Thomas, if you can join me on stage. I think Shakil is here. We're just going to wait for a second. All right, we just to a few more seconds. If Shakil is not here, we're just going to move on with Thomas. I believe Shakil is at the airport. I apologize for this technical issue. I believe he's at the airport. Could be a bit tricky to join. Great. Hi, Thomas. How you doing?
Good, thank you. Very nice to meet you.
Yeah, definitely nice to meet you. Great. So I'm going to pull up your presentation. And if you can pass the slide, that's perfect. Or you can say next, and I will pass the slide, okay?
Wonderful. Well, thanks everyone for joining. I think also very interesting talk just by the fireplace just now. And today we're going to talk about electric motors and predictive maintenance. And yeah, we as a company, Semantics, next slide please. We are a predictive maintenance company that actually leverages AI and machine learning algorithms to detect developing faults on industrial electric motors. We are founded in 2015 in Leiden, in the Netherlands. Actually, we're currently located, and with over 100 direct customers, and also with over 100 employees from all over the world. Actually, next slide, please. And well, the problem we are solving here today is actually quite large, because the electric motors are actually also considered the backbone of the industrial industry. So they can be steel making, the chemical industry, the water industry. Electric motors are actually widely used to produce all kinds of things that we use on a daily basis. So they basically power the global economy and actually also consume 30% of global energy consumption, electric energy consumption. Then this is also, I think, a very large playing field that we are also focusing on. Next slide, please. And what is then exactly the problem that we are solving here? So one thing is that these motors fail unexpectedly. That causes a lot of unplanned downtime, actually negatively affecting the production output of industrial companies. And secondly, there's also a lot of energy waste occurring related to those electric motors. So there could be because they are used inefficiently or selected or not selected right. Then next slide, please. To first dive into the first problem, the problem of unplanned downtime, what happens often. So actually we see that various plants, be it a chemical plant or a steel plant, is actually experience a lot of hours of downtime. It generates a lot of losses, because each hour of downtime can actually be up to 10,000, but even up to 500,000 euros per hour of downtime. And also the problem has not been solved yet. And our solution actually detects 90% of upcoming failures on electric motors and also subsequent drivetrains as well. Next slide, please. The second, for our measurements, we use the current and voltage, and we apply Fourier transform and other mathematical methods to, and then also applying artificial intelligence and machine learning algorithms. With that, we're also able to provide insights in the performance. And since we are measuring the current and voltage, we can compare the performance with the energy consumption, and thereby also identifying motors that run inefficiently and provide recommendations to companies to reduce energy consumptions and also to reduce their footprint as well. So our solution actually is able to cut, and it's proven, 10 to 15% of the energy consumption, which of course is in these times a huge benefit to many companies. Then some more details on how this is actually achieved, a bit more about the product. Next slide, please. Thank you. So what we actually use or do, we use a couple of hardware components that are installed in a motor control cabinet. Those acquire high quality electric data. We send it to our cloud platform. We use it using or analyze it using machine learning algorithms. And second, we actually inform our customers in a variety of ways. One, once we detect a failure, or actually the algorithms will alert of us that, we inform the customer. And second, we also have a real-time dashboard that is actually showing the results 24/7. Next slide, please. Then an example. So we do it in a variety of industry dimensions, so chemical, steel making, but also on airports, for example, on the baggage handling system. As you can imagine, now that COVID is somewhat behind us, the airports are getting really busy, and any delay because of a baggage handling system that's failing is directly affecting the passengers of an airport, because they won't not make their flight and so on. So for example, let's say we make a detection, we then inform the customer, they receive an email or a call, and we typically are able to do that weeks or months in advance. And then we are actually able to also connect with their existing systems and create a work order. And then they provide us feedback about those incidents. Next slide, please. Just to give an impression of our current customer base and the industries that we focus on. So really the large industries or large producing companies in the steel, petrochemicals, water, and then some other food and beverage companies as well. Next slide. Finally, one example in the steel making industry is for a hot strip mill. So there's actually transporting the hot plates after they have been casted. Last year, we actually detected 25 failures, saved over 100K per detection, and therefore the payback time was actually less than 6 months. It is actually a stellar case that showcased the power of predictive maintenance. And then before we close out, just to give you an impression, how can you then install it? Next slide, please. So typically, we just ship the hardware, we train the people on the site to install it. There's a tuning phase where the algorithms tune, with a baseline. And second, there's a go live phase, and there's a continuous data flow and also analysis. And then to summarize all of it, next slide, please. Yeah, at number 1, high frequency measurements from the motor control cabinet. Second, the gateway that connects to the cloud or actually does the initial analysis. 3, we perform a Fourier transform. Number 4, we actually detect specific fingerprints of failure, so we can be very specific. For example, on a motor there's unbalance or coupling misalignment, etc. And then number 5, the algorithms are actually kept on trained by all the data that we acquire. And number 6, once we get an alert from the algorithms that there is a failure, our data scientist will verify it, and then we inform the customer. And then finally, upon request, the slide why large corporations should work with us. Next slide, please. Yeah, so basically we have a very unique proposition. So currently there's no other company that has it actually marketed as we did today, relevant to today's challenges. Namely, we actually address the energy problems of today, and also the predictive maintenance, reducing unplanned downtime. Track record of successful implementation. So actually we are having a customer base of over 100 customers, as you just saw in a small impression of, and a proven ROI on multiple use cases. And finally, we actually have gained the trust of ABB and Schneider Electric, as we have a global partnership with both of them, and they're actually resellers of our solution as is. So thank you for listening to my pitch, and let's be in touch soon. Thanks.
Thank you so much. Thank you, Thomas.
Thank you.
Bye-bye.
See you.
Great. Bye. Great. So we have Shaquille from Glortech. So we're going to move on. Glortech, can you hear me?
Yeah, I can hear you. Can you hear me?
Yes, we can hear you. You would have to speak a little louder,
Okay.
but we can hear you.
Okay, thank you.
And you can say next, please.
Great. So yeah, thank you everybody. Good morning, good afternoon. Sorry, I didn't put the video because I'm actually at the airport. So my name is Shaquille Ahmed. I'm the head of global business development for Glortech. We're actually headquartered in Portugal, north of Lisbon. And essentially we focus around digitizing industry processes. Next slide, please. So in a couple of words, what we do, so essentially we provide solutions for connected workers on the field or on the shop floor or on the field services. Our main drive is to help individual connect workers to be more efficient. As you know, over the last industrial revolution, many of the digitization has been very much centered around machines. However, we still need people because machines are not self-healing. So what we do is we provide a digital tool that allows you to be more efficient using different technologies, including AI and augmented reality. The outcome that we're looking for is essentially to improve the operational efficiency, as I said, so increasing production increases, it's ensuring that you get the errors down to as low as possible. Training time is quite key because many of our customers are looking to improve their training capability, reducing unplanned trips, which is quite important, particularly looking at carbon footprint. And most of our customers say that the payback is within a year. So on your left, you see here is a use case where we're applying digital augmented reality for the airline company Embraer, and we have a number of customers today. Most of them are quite large in different market segments, paper and pulp, automotive, airline, and electronics. Next slide, please. So why should large companies work with us? Well, essentially, we have a solution which is extremely simple and highly scalable, extremely fast to deploy, so the return of investment is extremely fast. extremely factor customized because a lot of our customers need to work with different types of use cases. The system integrates with existing information systems, so many of our customers make sure that this becomes an integral part of their operating system. And we support a number of technologies, state of the art, everything from 2D right up to the augmented reality, applying mobility solutions. So in a nutshell, what we do is we provide a solution that allows frontline workers to be more efficient using technologies, and be quite keen to discuss and share more with you if the opportunity arises and if you're interested. Next slide, please. So just to summarize, Glartech is essentially a company that is focusing on connected workers. We've been around since a little bit over 8 years, and we have a number of solutions that's been globally implemented and highly scalable. So I'll stop here. Thank you very much for your time, and I hope to be in touch with somebody later. Thank you.
Thank you, Shakil. We made it work. Great from the airport, I believe. Thank you so much. Great technology. Thank you again for joining today. Great. So we are going to move on with George from Litmus. I believe he just needs again to adjust his camera, his microphone. He's going to be here in a second. Hi, George. How you doing?
Hi, I'm doing great. I hope you can hear me well.
Yes, I can hear you perfectly and see you. So yeah, thank you for being here, and it's yours.
Yeah, great. Thank you for the opportunity. So who is Litmus? So Litmus has been doing one thing since 2015. We've been getting data out of diverse shop floor assets and turning that data into something useful, something that data scientists and modern applications can actually work with. Today, we are productive in more than 150 factories worldwide. I always emphasize productive because there's a lot of proof of concepts around, but the real proving point is how long have you been productive? How mature is your solution? That we see all of the time. We have 3 regions. We're originally a Silicon Valley company, so our headquarters are based in Santa Clara. We have offices in Toronto, an office in Tokyo for the APAC region, and I'm in charge of the EMEA operations, which are headed in Munich, Germany. Next slide, please. So I said we get data out of heterogeneous shop floor assets, but let's start where most of our customers actually are today. So for a typical customer, and again, our customers are production companies, whether discrete or process manufacturing. For a typical customer, the current data infrastructure looks something like this as of this moment. Grossly simplified, of course, and only exemplary vendors, but basically it consists to the largest part of capable mission-critical control systems, which in their structure have been around since the 70s. So that's the column on the left side. Now, in traditional ways, what are you going to do with that data? So you're going to store that data in purpose-built industrial systems. We call them legacy systems because they do things in a very specific, very purpose-built, very proprietary way. So let's assume you have these systems and these data loggers in place. Now, where do you traditionally use that data? In HMI systems, in SCADA systems. Again, legacy or purpose-built applications. Basically, you build it once, you never change it for the lifetime of the asset. Next, please. Now, okay, one back, please. Oh, yes. Okay, you remove the animations, but that's fine. So basically, this is not static. This gets more and more complex over time because systems are added, further increasing the complexity. So these traditional purpose-built, use case specific, factory specific, industry specific silos. That's the data infrastructure where we mostly start from. If we move to the next, please, now. So that's not the whole thing, however. That's the left thing. That's the OT infrastructure. But now things have changed, and there's more available. There's the whole right side available. These are the modern systems, the IT systems, the cloud systems. This is really where the value is created today. This is where the top talent is. This is where the billions of investments go. Now, if you want to work with this data on the left side, in those modern systems, create the value that these systems offer. And this is tremendous value, as we know, again, just symbolified by exemplary vendors here. Now, what you have in between is a big problem. These are years of integration. These are people, teams of 5 to 15 people at many companies doing nothing but that. And once you have established such an infrastructure, it will break. So why will it break? Because some user, some company on the right-hand side changes an interface, or because some startup there dies and you have to use a different company, or there's a new offering that you want to profit from. So we have asked ourselves, how can you make this more sustainable and more scalable? Next, please. So that's the reason why we built Litmus as a data infrastructure. So I avoid the term platform because everyone uses platform. Of course, it's an IoT platform for industrial applications. But the better term is actually data infrastructure, because that's what it actually is. It takes the data from the left out of these OT systems. How do we do that? We have the largest set of drivers in the market, currently around 260 drivers. So we can connect to any system that you have there, be it a PLC, be it flat files, be it SCADA systems, be it vision systems, be it laboratory information systems. So connect to all of these natively with a couple of clicks. It's all graphical. We standardize the data, we normalize it, we make sure it's not just a tag, a value, and a tag name, but that it has context. So it tells you which plant, which area, which line, which machine, which type of asset, and so on. So you can actually model data. And then we process the data, or rather, we give you the tools to process the data. All of that happening on the edge, as close to the data source as possible. Either you do that with our apps, or you use your own apps for that. And then we integrate to these modern systems, be it Google Cloud, who is white labeling our solution, which is called Manufacturing Connect then, be it AWS, which a lot of our customers use as well, or Azure, which a lot of European customers use, or any of these other applications, be it in the cloud or be it on-site. We do that in a very modern way, with security built in from the first moment, starting from the development processes, going over the operating system up to authentication, authorization, all the stuff. We do it fully integrated, so it's a ready-built productized solution, and we do it with a very simple UI, with a very accessible system, because obviously the greater the value, the greatest value you create if you democratize the access to this data. So usually OT data is accessible only to a few experts, but we make that data available to anybody you wish to give access to in your company. Next, please. So summing it up, we're the data infrastructure, which is built for three challenges in particular. One is speed. So our customers roll out between 3 and 20 plants in 1 year. We're always focused on multi-plant companies. That's why scale is our second focus. Companies that want to scale out an IoT solution to a large number of plants, and security, which is an utmost concern to most of our customers. We have independent security audits. We can provide a lot of information on how we do security. So companies coming to us are usually looking for those three properties: speed, scale, and security. That's the end of my presentation. So I'm very happy to enter into a dialogue with you. So please feel free to reach out. Just seeing my coordinates are not here. I'm sure there's a way to get them over Choose Paris.
Yes, that will send the. Thank you so much, George. Very interesting technology. It's really in line with what we were talking about, data complexity and those kind of subjects. Thank you so much for joining today.
Thanks for the opportunity.
Bye. Bye.
Bye.
Great. So we are going to move on with Crosser, and I believe Andrea is going to join me in a second. Great. Hi, Andrea. How you doing?
Hi, good. How about you? Thanks for having us all here.
Yeah, definitely. Thank you so much for joining, and the floor is yours.
Super. All right. Hi, everybody. My name is Andrea Magnago, Director International Sales at Crosser. We're all about intelligent and low-effort integration of all, and I want to emphasize all, your data. That's kind of the headline of the presentation on what we do. Next, please. Quick intro about the company first. We're a Swedish software company founded in 2016. Headquarters in Stockholm, which is where I'm situated today. We have also presence in Germany to cover the region. We basically provide a software for stream analytics, edge analytics, and integration designed for industrial companies. So that's our DNA. We're backed by solid investors, a mix of Swedish, German, and Japanese VCs. And we have customers in multiple verticals within the industrial space, process industries, metal, and so on and so forth. Some of these customers have left some reviews, detailed reviews on Gartner Peer Insights, and so far we have a pretty high score that we're proud about. So that's kind of a nice testimonial from people using Crosser. Next, please. So why do we exist? Crosser is actually born at the intersection of the old world and the new world. A bit like Eva said at the beginning, yes, there's a lot of legacy stuff out there that needs to be connected and integrated. So we want to be that glue or that real-time integration bridge between the old and the new. And it's not only about IoT data, machine data, which is at stake here. It's about all kinds of data. It's machine data, it's systems, system data, and so on. And it's combining that data, contextualizing that data, transforming that data, harmonizing that data all together, which can then produce value. So we want to be that glue in the middle to basically address this complexity of old meets new, basically. So that's what we do with streaming analytics and integration capabilities. Next, please. So this means that it's all about data, essentially. It's about bringing in and integrating and processing any kind of data. It could be data at the edge, real-time data at the edge that you can extract from machines and sensors, as we heard from Litmus previously. So it could be PLCs, it could be sensors, it could be cameras as well, but also other, picking up data from other on-premise systems, ERP systems, databases, but it could also be other cloud data sources as well. So any kind of data, and out of this, you want to enable all kinds of use cases within the kind of digital 4.0 journey. It could be integration use cases. It could be those typical edge analytics use cases where you want to process in real time that machine data. You might want to deploy machine learning on that live data, inspect images from cameras, vibration data, for example. So those classical edge analytics use cases combined with other integrations, either on-premise or on the cloud. That's what we enable with Crosser. So anything to everything is the bottom line here. Next, please. So the landscape can be quite complex, actually. If we look at this architecture, typically you would find Crosser, for example, running on-premise at the bottom of this slide. So connecting directly to machines, to cameras, to PLCs. So really getting that real-time data from the factory floor, that's a very common case where Crosser is used. So on-premise, picking that data, processing, transforming the data in real time and doing something with that data. But that's just one part of the whole let's say puzzle, because there's other data sources at stake here. There's cloud applications, there's data lakes, different cloud providers, databases, and so on and so forth. So Crosser can also exist further up in the architecture, in the stack here, and do all kinds of our integrations also on that level here. So when we talk about Industry 4.0 projects, it's different data sources, it's integrations on-premise, at the cloud. I mean, we have customers that don't have any cloud, but still there's a lot happening on-premise. And on the other hand, we also have a lot of customers that have both on-premise systems, cloud. And again, you need to bring all that together in a seamless way with real-time actions and logic. So that's a little bit looking at the kind of the overall complexity here. Next, please. We bring simplicity to our customers. We do that with low code, which is, I guess, a very hot topic nowadays in a lot of different industries. So it's very visual. It's a bit like Lego. You connect little Lego pieces together, which we call modules. And like that, you basically create your flows, your data pipelines, which basically represent your use cases. This is just an example here of a typical on-premise to cloud or OT to IT integration, bringing in OT data, transforming, processing that data in real time here in the middle of the flow, and then delivering those insights to Azure or to some other cloud, to maybe an ERP system, or basically even writing back to machines. So very visual, makes the journey much more agile and flexible instead of having to reinvent and programming every single line. So that's a very important part of what we deliver, low code and simplicity. Next, please. One of our customers in the food industry that is leveraging this kind of low code and kind of agile development, we saw that in the first year, they were able with a small team to actually deploy and develop more than 80 integrations, 80. Very impressive 12 months where they actually did a lot with a small team here. I mean, if we look at the next slide, we actually see who it is. Next, please. The customer is actually Clairbout in Belgium. You might not know this brand, but you might have eaten their products. They're a global leader of frozen potato products, fries, essentially. And Clairbout has been using Crosser for those typical OT to IT integrations, a lot of on-premise data processing, connecting their process lines, getting that data, integrating with their ERP, with their MES systems, and so on. Very nice example of a customer that in the space of very little time managed to build more than 80 integrations within a short time frame. We have a blog actually describing this case if you're interested. Next, please. I think this is one of my last slides here, and so basically I invite you to reach out to me or to Crosser, to anybody at Crosser, to look at some of these use case examples that we have here in the screen. And these are examples of really common use cases that we see at our customer sites, ranging from typical edge analytics, getting that data, transforming that, harmonizing that, integrating with IT. So this OT to IT integration, more advanced analytics, machine learning, vision inspection, all the way to more kind of hybrid integrations on-premise and cloud, basically bringing everything together. So I encourage you, and very welcome to contact us and basically drill down into some of these use cases that could be relevant for your projects. And the final slide. Yeah, so what we promise and what we try to deliver is basically simplicity, as I said, with low code, but also to diminish complexity and the cost of the data stack. So one of the things that I don't think we touched much in the session today is costs, and things like cloud cost, integration costs. They kind of go up the roof very, very quickly. So with this type of solutions, we try to diminish complexity, diminish those costs, also costs related to engineering and development, and speed up things. Get test, trial and error test, deploy fast with agility and low code. So that's what we're all about. And I think with this slide, I'm done. Thank you very much.
Great. Thank you. Thank you so much for your presentation. Very clear. Thank you. Thank you again, Andrea. Bye-bye.
Bye-bye.
Great. So we're moving on with Lenent AI. Jax, so for your presentation, so the floor is yours.
Thank you. Good day, everybody. This is Jax Kandasamy, co-founder and CEO of Latent AI, coming to you from San Diego, California. Latent AI is an on-prem MLOps platform to help you secure your neural networks, right? Optimize and secure. Next slide, please. We are a company founded on the backs of DARPA technology spun out of SRI International. For folks that are not familiar with SRI, if you're using Siri, Siri came out of SRI, right? So we follow that, the lineage of deep technologies that come out of SRI. We are offices located in both coasts, California and in New Jersey. Team of excellent industry veterans, startup veterans, as well as researchers that form the backbone of Latent AI. We are invested by significant venture capitalists as well as defense-focused Lockheed Martin and Booz Allen as well. Right. Next slide, please. Probably most of the organizations have tried to build ML models and tried to deploy them onto the edge and figured out that most of them fail. A lot of them are done in the prototyping phase. You have all of these cloud resources accessible. So you build the model there, you test it out, and then you figure that you cannot put like a server rack onto your factory floor or next to your maintenance station, right? That's not possible. So that's the reason most of these models, most of the AI projects fail, right? If you want to, you could probably prototype and put it on one installation, and then you want to go scale it to 20 other locations, and the cost of scaling becomes unsustainable, right? Next slide, please. So what we offer is an on-prem MLOps solution, right? Our tooling is directed at engineers. If you think about data science expertise and ML engineering expertise, if it is on a scale from 1 to 10, 10 being like, a senior PhD data science person, our tool is more targeted towards the 6 and 7s and continuing to evolve towards going to a level 3 engineer. So we want to take the dark arts of ML into more of an engineering problem. That's basically what we provide with our tooling, right? Next slide, please. So we did a recent study. So why use our tooling, right? We did a recent study. It was funded by AWS, done by a third party. Even on the cloud, our MLOps pipeline generated runtime runs faster and gives you cost savings, right? We are able to improve your time to market using our MLOps pipeline, so your projects don't need to sit in the pilot purgatory forever. You can quickly prototype and quickly deploy it and test it out, and then you can scale from there pretty fast as well, right? Next slide. Our goal, with AJAI, if you think about it, we're trying to create a sensory cortex for a UXV platform, right? We are on multiple contracts right now with the U.S. Department of Defense, a couple of oil and gas companies in utilizing unmanned vehicles for multiple use cases, right? Think of it, you want to put a sensor in there like vision sensors, audio sensors, IR sensors, sonar, LiDAR, whatever that may be, collecting the data, but processing it on board before you send in that stream of data that people don't know what to do with, right? That's basically what we are helping with, creating that system of system concept where you can make your UXVs, your UX platforms more modular and be capable of delivering values when you need them, right? So the idea, different customers have different needs, but most of them all need the data compression part of it, right? You don't want to be seeing all the data that is coming in, because 95 to 98% of that data that comes through is benign, and it's not useful for anybody, right? The signal is only in the 2%. How do we filter that 2% out and only send that so that you are not overridden by cognitive overload on the data that comes in, right? Next slide. As I said, a couple of commercial engagements we are showing up here. We're working with an agtech company on increasing their speed of deployment onto the tractors. Their training time used to be 2 weeks, and then deploy on the tractor. We reduced the training time from 2 weeks to about 20 minutes. And we increased the inference speed by 150%, so they can drive their tractor faster doing their work on precision farming. The oil and gas company that I talked about, we are doing an underwater unmanned vehicle pipeline inspection. Before us, they were collecting footage from every run and then upload it to the cloud and process it on the cloud, which could be like a 3 to 4 day turnaround time if they found any issues. With us, they're able to run compute on board, and they're able to figure out if there is any anomalies that are there on the pipeline and can send a diver immediately. We are part of the 5G Open Innovation Lab. We are redefining the network to be more of a compute engine rather than just a dump pipe. All right, next slide, please. So I invite you to come learn more about the Leap SDK, our key platform, and help. This is our platform is for engineers who want to build their own solutions internally, because we realize there is a lot of knowledge that is within an organization that is that's not available outside, right? And you know your systems better, you know your processes better, and you can define the domain better than anybody else. So we help you with the tooling to build your own solutions and to deploy them, right? So we welcome an engagement, and there's my contact information. Please send me an email and we can set up time to talk. Thank you.
Thank you, Jags. Thank you for your presentation. It was great. Thank you so much. Great. So we are going to go with the last presentation. So base 2 with Kiefer. Kiefer, can you hear me?
I can indeed. Can you hear me?
Yes, perfectly. Thank you so much. And yeah, the floor is yours.
Awesome. Do you actually mind if I share from my end? Is that possible? I have a slightly updated slide deck.
Yeah, you can try the share button at the bottom, and at the top there is the share screen.
Awesome. So I'll hit share just so I make sure this shows up properly. Can everyone see this?
Yes, I can see it.
Awesome. So hi everyone, my name is Kiefer. I'm the head of product here at Base 2. I'm going to be talking to you about the first end-to-end platform to operationalize digital twins. A little bit of background on Base 2. We're a venture-backed software company. We're really focused on empowering engineers to operationalize digital twins. Digital twins has kind of become a buzzword in the industry, especially across Industry 4.0 initiatives. What I mean by digital twin is essentially a process model or a process simulation, anything that's focused on using data to improve either an asset or a process and its productivity. We're part of the Johnson & Johnson innovation ecosystem and have partnerships with Boeing and GKN. Via Aerospace Accelerated. We have offices in Toronto and San Francisco, and I have a few of our investors from the Boston and Bay Area highlighted in the slide as well. Going into the problem statement, I think this is going to be familiar to everyone here. We know that engineers across the process industry want to improve KPIs like productivity, process efficiency, competitiveness, using things like plant yield increase or reducing emissions and energy consumption, or even just lead time reduction. But the problem is that a lot of engineers are over-reliant on legacy or desktop tools to improve their production performance, whether that be just Excel spreadsheets or MATLAB scripts or Python or Jupyter notebooks, or even desktop flowsheet simulators that really don't integrate across an organization's tech stack. This problem is why we built Base 2. We're the first end-to-end digital twin platform specifically designed for the manufacturing and process industry. At a 10,000-foot view, here's what we do. We basically allow engineers to reliably build, validate, and deploy these models of their processes or assets using the following 3 pillars. One is extraction. So for example, we can connect to a variety of industrial data sets like a SCADA DCS or LIMS or CMMS, centralize that data on the Base2 platform, and then give engineers the tools to build a standardized data pipeline to clean and pre-process that information, get into a usable state, and then give them the tools to actually build a simulation or a model to explore their process in a virtual environment. And then they can use it for optimization use cases, such as learning how their process would perform under novel conditions or finding the best time to maintain or replace an asset. And to make this really tangible, I think the best way to explain it is via a couple of use cases. So I just wanted to highlight two. Before I go into that, just a note that Base2 can be applied across the manufacturing and heavy industry. We see a lot of deployments in pharmaceuticals, energy, and chemicals, but also see a lot of pull from aerospace manufacturing, food and beverage, metals and mining, and a bunch of other industries as well. Going right into it, this first use case is exploring optimization of a commercial scale bioreactor. This is a pharmaceutical application. And just like the workflow in Base2, there's 3 steps to this. There's extraction, simulation, and optimization. So what we did here is we extracted historical data from the critical process parameters in the yield of the bioreactor, things like concentration, CO2, temperature, dissolved oxygen, pH, things like that, and then clustered and classified the batches based on their titer or yield. So high performing batches versus low performing batches, and then investigated the differences in the parameter behavior throughout the fermentation process. So if you look at something like dissolved oxygen over time, you can see that in the blue line, the dissolved oxygen is actually decreasing over time across the fermentation process versus the average batch, which is the red/burgundy line, where it's a little bit higher. So if you can take that control strategy from the highest yielding batches and align the behavior from the lowest performing batches with those in the well-performing ones, essentially a golden batch approach, you can improve yield across the factory. And we are able to do this and improve final yield by up to 33%, which especially at commercial scale is obviously significant, which is a great achievement. And then going on to the next one, this one's a little bit different. Here we're more focused on the asset. So this is predictive maintenance of heat exchanger fouling. Classic problem across a variety of different industries. The same kind of workflow was taken where you can extract data from the heat exchanger, mass flow rates, outlet and inlet temperatures from the hot and cold streams. And then instead of taking a data-driven approach here, a hybrid model was built to actually incorporate some of the mechanistic understanding from the heat exchanger. And this basically allows you to create a more reliable, a more accurate model of the heat exchanger, even in low data environments or situations. You can see when you look at the actual versus predicted, it's easily able to capture the dynamics of the system. And this can predict when heat exchanger fouling occurs and allow you to clean and maintain it before it introduces any sort of problems in your final product quality. And this can save manufacturers up to $3.6 million per year. That's for a large site. It's going to vary depending on the deployments and how many heat exchanger fouls you have as well, of course. And lastly, just in the last minute, why Base2? Our team brings decades of experience across the engineering-centric product development. We have more than 20 team members across North America and EU. We have a lot of experience with Fortune 500 and industrial companies. Again, it's that regulated industry experience. And we're all about building scalable software across NASDAQ big tech companies. Here's some of the logos where we've worked. But more importantly, what we bring to the table is this engineering-centric AI platform capable of solving design and operation use cases across the heavy industry. We really understand regulated industries as well. That's kind of our niche or our specialty, with emphasis placed across aerospace, chemicals, and pharma and oil and gas. And with us, you have the opportunity to build really customized or bespoke domain-specific solutions alongside a fast-growing startup. And we have some of our major partnerships here in Johnson & Johnson, Merck, GKN, Boeing, and NOV. And on the flip side, in terms of what we're looking for in a partner, is someone who has access to historical data of the key assets or processes they're looking to optimize. In-house engineering expertise is also key because these are the SMEs that we'll be consulting with to ensure the models are validated. And lastly, interest in digital twin or AI technologies is always valuable. And if there's existing pain points for digitalization, that's all the better. And I think that's it. I know it's the last presentation and we're a little bit past time, but hopefully that was efficient. So I'd love to chat. We have a few of our contact information here. Thank you for the opportunity.
Thank you so much. That was great. Definitely interesting to see, even if we are at time. Thank you, Kiefer, and thank you again to all the presenters. Before we end the meeting, I just wanted to share the agenda for the next events that we have. So our next tech meeting will be on March 2 around hydrogen, and then on April 6 around supply chain and logistics. So thank you again to all the presenters. I hope to see you soon. Here you have the contact information of Ellen Tanti, who is the head of development. She's dedicated to large corporations. If you want to join the Global Open Innovation Network, and as well as Cécile Jupin, who is the business development manager for startups, and she's helping with the expansion in the Paris region. So thank you again, everyone, for coming by, and have a great day or evening until next time. Bye-bye.